Let's continue on with 3.2. Now in 3.2, we'll now look at the more traditional ways that you have learned what we just did in 3.1, okay? Because in normally what you've learned is that what happens when the lines are parallel, correct? So if you have two parallel lines here, so we indicate they're parallel by doing this, they're parallel, and you have a transversal line that goes through here, okay? Then the postulate 3-2-1 says, if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. In other words, this guy and this guy are congruent because they're corresponding angles. This guy and this guy are also corresponding angles. And then this guy and this guy are corresponding angles. And then also this guy and this guy are corresponding angles too. As a matter of fact, if you think about it, right, let's say that this was 60 degrees. If this was 60 degrees, this guy here will be 60 degrees. And this guy here is going to be what? What is this angle here going to be? Can anybody tell me what that angle is going to be?
120.
120. Why? Why is it 120? Because these two have to add to 180, correct? They have to add to 180, right? So 180 minus 60 is 120, which means that this guy is 120. But this guy and this guy are vertical angles, so it's 120. This guy and this guy are vertical angles, so this is 60. These guys are vertical angles here. So in other words, there really are only two angles here. You're either going to be 60 or you're 120, right? And they're all kind of the same here, right? Okay. So example number one, if you look at example number one, we have example number one, we have two lines that are parallel. They are cut by a transversal, and they're giving this guy here as 80 to us. And find this angle right here. Well, this angle is going to be the same as that because they are corresponding angles. So this guy here is going to be 80 degrees. And then on the second one, they're giving us a whole new set of lines here, and we have here, and these guys are parallel. And then you have this guy here as 2x minus 45. Then you have this guy here as x plus 30, okay? But since these are parallel, that means that these two angles are corresponding, which means they must be the same. So I have x plus 30 is equal to 2x minus 45. I move the 45 over, I get 75. Move the x over, I get 2x minus x. It's going to be x. So x is going to be equal to 75, which means that this guy here is going to be 105. Let's verify this is correct too, because 2 times 75 is 150. 150 minus 45 is 105. So yes, indeed, they are the same. Okay. Okay, flip the page, page 156. There are 3 separate theorems there. First one says, if you have two parallel lines that are cut by a transversal, then the pair of alternate interior angles are congruent. The alternate interior angles are congruent. Then 3.2.3 says the alternate exterior angles. So the alternate exterior angles are also going to be congruent. Then 3.2.4 says the same side interior angles are going to be supplementary, right? In other words, this guy plus this guy is 180, right? And how would you prove that? You'd prove it by saying that this guy and this guy here are congruent because they are corresponding angles. And this guy plus this guy, since this is a line, has to be 180. Therefore, these two angles are going to be supplementary. Okay? Example number 2. Let's see what we see. Example number 2. Find the angle measures. Example number 2. Find each angle measure. We have two lines that are parallel like this. And we are told this is 125. And what do we want to find? Find EDF, EDF. So we want to find this guy here. So this guy's going to be what? Evan.
55.
What?
Will it be 55 to equal 180?
No, because this is 125. What is this? What are these two angles called?
Oh, hold up. Let me just look at my notes real quick.
These are called alternate exterior angles, right?
Yeah.
And alternate exterior angles are going to be congruent when you have parallel lines. So this here is going to be 125. Okay?
Okay.
All right. All right. Okay. And then where we have? Then find the next one. We have what? This is 13x, and this guy here is 23x. And they want us to find TUS, TUS. So you want us to find this angle right here, okay? So how would I go about doing this? Jose, tell me how I would go about doing this. What are these two angles called, first of all?
Or example 2B.
Huh?
Example 2B.
Example 2, yeah. Example 2B. What are these two angles?
Aren't they same side interior?
Same side interior angles, which means what?
That they are supplementary.
They are supplementary, exactly. So you would have 13x plus 23x is equal to 180 degrees since they're supplementary, right? So we're going to add these two together. We get 36x is equal to 180. X is going to be equal to 180 divided by 36. It's equal to 5. So x is equal to 5. Therefore, this guy here, 23 times 5 is going to be 115. Okay, and if you calculate this guy, it's going to be 65. So 65 plus 115 indeed is 180, as it should be. Okay. So that's example number 2. Last but not least, let's go on to example number 3, which is titled as music application. Music application. The treble strings of a grand piano are parallel. Viewed from above, the bass strings form transversals to the treble strings. Find X and Y in the diagram. Okay, so we have 3 separate parallel lines here. Then we have one line that looks like this, and we have another line that looks like this. And we are told that, what? Okay, find the X and Y in the diagram. I am told that this is 125. And this guy here is 25x plus 5y. And then I have this as 120. And this guy here is 25x plus 4y. Okay. So I have what? So these two angles here if you look at these two parallel lines, are alternate exterior angles, which means they're the same. So I have 25x plus 5y is equal to 125. And then I have from these two guys, I have this guy and this guy are corresponding angles. Because these two are corresponding, so I get 25x plus 4y is equal to 120. So I have a system of equations, two system of equations. How would I go about solving this? Carter, how would you go about solving this?
Well, so you can say that 125 are alternate 125 is an alternate exterior angle to the 25x plus 5y.
We already did all that. So I already got that set up. Tell me how to solve these
okay.
system equations.
Well, first,
What are the two different ways to solving system of equations that you were taught?
Well, you substitute y.
Substitution, right?
Yeah.
Okay.
You would. So you'd substitute, if you want to find x, you substitute y for 0, and vice versa.
No. So substitution means that you would solve for x and y on one of the equations, and you would go ahead and substitute that into the other one, correct?
Yes.
Because that's the substitution, right? Elimination, which is the other one, is you would eliminate one of them by adding or subtracting, correct?
Correct.
All right, so in this one, which would be easier?
Substitution.
Why would substitution be easier?
Well, because then you can find both of them.
So which one would you substitute here?
Let's substitute 120. Or sorry,
When you
x.
substitute 120. So when you're substituting something, you're substituting the variable, correct?
Yes.
So from one of them, you have to solve for either x or y, and then you're going to put that back into the other equation, correct?
Mm-hmm.
Okay, so there's two ways to work this. Okay, the easiest way really here is to do the elimination. You do the elimination, you just subtract this guy from this guy, right? So the 25x and 25x will cancel out. 5y minus 4y is equal to y. 125 minus 120 is 5. So bing, you immediately get to solve for y, right? So then you would go ahead and solve, put the y in here, then you have 25x plus 5 times 5 is 125. This is 25, so if I subtract the 25 out, I would get 100, divide by 25, x is equal to 4. Okay, so this is how you would do the elimination method, okay? To do the substitution method is a little more time consuming here, but it's not too bad really. So let's see how we would do the substitution. So if you do the substitution, right, you have to solve for y or x here, right? So it seems to me that you would want to use this one because this is divisible by 5, divisible by 5, and divisible by 5. So from the top one, you would get, if I divide by 5, I'm going to get this. You get like this. And then y would be equal to, if I move the 5x over, minus 5x plus 25. Now I would go ahead and substitute that guy into here. So I would have 25x plus 4 times 120. So 25x over here, from here, I'm going to get negative 20x. So So 25 minus 20 is 5x. Then I have 4 times 25, which is 100. It's equal to 120. If I subtract 100 from both sides, I end up with 5x is equal to 20, x is equal to 4. Then I would put that guy back into here, and I would have negative 5 times 4 plus 25. So I have negative 20 plus 25 is 5. I get the same result. A little bit more work, okay, but not too bad. Okay, all right. The more advanced method of using a substitution is on this one. What you can see is that you have this guy and this guy are the same. So instead of solving for x from the top one, I'm just going to solve for 25x. So 25x is 125 minus 5y. If I move the 5y over, then I would substitute the 25x into here. So I'm going to get 125 minus 5y plus y is equal to 120 minus 5y plus y is going to be minus 4y. I move this guy over here. Okay, what am I doing wrong here? Minus 5y, move back, 25. Oh, this is plus 4y, I'm sorry. Plus 4y, so this is going to be just negative y, right? Minus 5 plus 4, so it's minus y. Move this guy over, I get minus 5, so y is equal to 5. And I put that guy in here, I get 125 minus 5 times 5 is, this is 25. I get 100, so 25x is 100, therefore x is equal to 4. Same result, okay? But this is a kind of a more of an advanced way of looking at it, okay? Because you notice that the 25x and 25x are the same. Okay? Any questions? So a brief review of some algebra stuff in there. And so we are done. We are done with 3.2.